Hello, this video is about schematics and how we use circuit schematics to make our life easier. Now, in the introductory video, I said there were 4 ways that you could light a bulb with one battery, one bulb, one wire. And here they are. So we've got one battery, one wire, and one bulb. We can kind of just swap where the bulb is, and if we're touching the tip of the bulb to the battery or the threads of the bulb. Now, physics-wise, these are all the same circuit. They're all one battery, one bulb, the bulb is lit. If I'm going to be talking about a basic one bulb, one battery circuit, I don't want to have to draw this and say, oh, but it could be this, or it could be this, or this could be this. So what we do is we use a schematic to show we're talking about a single bulb, single battery circuit. So here is what the schematic for all of these would look like. All right, so what do we got? This symbol with a long and a short line, this is the battery. This is how we represent a battery, and we've got a positive and a negative. The squiggly thing is the bulb, and that squiggle represents the filament inside the bulb. So if you've ever looked at a filament, it is it's a double spiral. And then we've got wires, more or less. These might represent physical wires, they might just represent a connection, some sort of connection. And so all 4 of these are represented by this same circuit. So when I say, here's my circuit, you could build any 4 of these and that would be fine. So this is a way to give visual information quickly and more simply than this more complex. Could be any one of these. So battery, long and short, positive and negative. We've got the bulb with the circle with the little filament, and then we've got some basic wires. What else do we have what other electrical devices are we going to be talking about? Well, one of them is a basic switch, like a light switch. So you've all used a light switch a lot of times. So here's my battery, here's my bulb, and this is a switch. There's often 2 little dots here. Sometimes people put an arrow there to show, hey, this is a switch. It can go open and closed. So a switch looks like that. And now we can also talk about using schematics for multiple bulb circuits. Here I'm going to draw it a little bit smaller. Oh, roop, and roop. Plus and minus. So here's bulb 1 and here's bulb 2. Now think about how you would physically hook up 2 bulbs so that they behaved like this. There's only one path, again tracing the paths of conductors, there's only one path. We go into bulb 1, out of bulb 1, into 2, out of 2, back to the battery. So take one of these 4 and see if you can open up the circuit effectively and draw in a second bulb so that it behaves like this. Okay, take some time, give it a try. All right, it doesn't matter which one you start with, they're all going to work. I think this one might be the easiest to see. So if I have a battery, I'm going to go into bulb 1 and out of bulb 1. Great. Into bulb 1, out of bulb 1. And then what do? I go into bulb 2 and out of bulb 2. So I could add a second bulb like this, and now does it matter which way I add it? No. I'm going to make it look symmetric because I like symmetry. Like that. So here, let's trace it. Out of the battery, up through the filament, out of the bulb, into the bulb, through the filament, back to the battery. We've got a complete path of conductors, and it's all just a single loop. This is what we call a series circuit, where it's one right after the other. You can see that it doesn't matter how complex the actual physical, realistic thing is. This is what it's all going to be like. Because I could have said the other way to do it. We could do like that, or add one here. I could even add one like right here. Oh, let's see if I can do it now. Yep, if I do that. Those are all series circuits, one bulb into the other, one loop only. We can also talk about multiple loop circuits. So what if I have bulb 1 like that and bulb 2 like that? Now there are two loops, two paths. So how could we take what we've got, one of these, and add a second bulb that has its own path? So give that a try. Pause, give it a try. Okay, so here is one way to get a single bulb circuit that's lit. How can I add another bulb that has its own path to the battery? Because if you think about it, this bulb 2 has a direct path. One side goes to the positive, the other side goes straight to the negative. Well, I could do something like this. And right down like that. That would be one way I could get this to look like this, to be this. Now if I trace the paths of conductors, okay, so one path does this. Okay, that's easy, and so let's call that B1. That's that one. One path would do this. All right, and then we're back. And so that is this path right here. So this is one way that we could put two bulbs together. Each have their own loop of conductors. Each have their own path to the battery, connection to the battery. And in this case, we call this setup parallel. Okay, so here are schematic versions of a bunch of these circuits. And one more thing I'd like to try. I'm going to take the switch out, close it up. Oop. And let's see. Okay, suppose we have a bulb in a socket and we have the switch closed, or there's no switch, it's just lit, and we unscrew the bulb from the socket. How could we represent that schematically? What would we be doing? Well, we'd be removing the bulb. And so literally you just remove the bulb from the schematic, and now is this a complete path anymore? No, there's no complete path. This would be an open circuit because there's no complete path. And so literally just delete the bulb, erase the bulb. Another thing that I want you to think about, let's go back to this. So we have the basic one battery, one bulb circuit. In the open and short circuit video, I talked about adding a shorting wire. And how would you draw adding a shorting wire? So if you need to, go back and look at the actual realistic picture of one of the ways to short out this bulb. And if once you've reminded yourself of that, see if you can figure out how you would draw a shorting wire. There's lots of ways to do this. One of the ways would be to just say, okay, I'm going to put a wire from the positive end of the battery to the negative. And there is my path of lesser resistance. Most of the electricity is going to be flowing here. I could say, well, the interesting thing here, all of this right here, this is effectively one space, one spot. Everything here is connected. So I could actually just draw that as well. And that also would be a shorting wire because there's a path that goes from the positive end of the battery, and it's all wires all around. And so that would be another way we could short. So these are both telling me the same information. They're both a short circuit. It's just different ways to draw the schematic. I guess a third way we could even draw it like that because then there's path. So I want you to be thinking about paths, tracing paths of conductors, because that's going to be really helpful for figuring out what type of circuit you're dealing with and what's going to be happening in that circuit. All right, there's schematics.